Today we're going to start our study of trigonometry, which really just means triangle measurement. Most of what we do is going to be given in degrees. So a degree is 1/360th of one revolution, meaning that if you travel around in a complete circle, we have traveled 360 degrees. You should be pretty familiar with this. Angles are composed of two rays, and remember that a ray is essentially a half a line, or the portion that starts at a given point and continues infinitely in one direction. So if you take a look at the angle shown, one goes in this direction infinitely, the other goes in this direction infinitely. That's what the arrows mean. The vertex is where the two rays come together. When you're looking at angles, we have an initial side and a terminal side. The initial side is the place where you begin your measurement. So if you take a look at the way these two angles are measured, they start here and rotate. So they start on the initial side, they rotate over to the terminal side. You can actually go backwards as well. Here's the initial side. We begin here, rotate down or clockwise, and we end on the terminal side of the angle. Again, if you look at these two angles and the direction that they are measured, this angle on the left is measured in a counterclockwise direction. Counterclockwise angles are always positive, whereas the angle on the right is measured clockwise. Clockwise angles are negative. When we place an angle on a coordinate plane, we call that standard position. Standard position is always where the initial side aligns along the positive x-axis. All three of these angles are in standard position because the side that they are measured from is along the positive x-axis. The terminal side of the angle, then, is anywhere else. Angles' terminal sides can be in any quadrant, and the location of the terminal side will tell you what quadrant angle it is. So if you take a look at this first angle, it says it's a second quadrant angle because the terminal side is on the second quadrant. This angle is a positive angle because it is measured in a counterclockwise direction. The next angle is a first quadrant angle, although it's negative. It's actually being measured clockwise, so the angle is negative. However, because the terminal side of the angle is in quadrant 1, it's a first quadrant angle. This third one is what we call a quadrantal angle. Quadrantal angle is going to have its terminal side along an axis. Remember that all angles have their initial side along an axis, but for quadrantal angle, the terminal side is also along an axis. The one shown is 270 degrees. We could represent one that's 90 degrees. We could represent one that's 180 degrees. These are all quadrantal angles. Coterminal angles are angles that have both sides which coincide. There are infinitely many coterminal angles. You have to think of the terminal side of the angle like a hand on a clock, that it can continually rotate. And as it continually rotates beyond 360 degrees, the degrees are actually going to add up. So if you look at the first angle here, you've measured through 150 degrees. Moving on to the next angle, we rotate through 360, then we continue the rotation further, an extra 150. So here we've got 150 plus 360, and they're showing you this 1 times 360, meaning it's gone through one full rotation of a circle plus another 150. If you take a look at the next one, it rotates through 360 once, and then again, and then finally through the 150 degrees. So again, we've gone through 2 complete rotations and then added onto it. So that's why we've got 2 times 360 plus 150. This works going in a clockwise direction as well. What we do then is we begin to subtract. So here, if we begin at the initial side and begin moving backwards, okay, a full rotation would have been 360. That's what this is. The -1 shows that we moved in a clockwise direction. The 150 was this measurement. So an angle of -210 is going to look exactly the same as an angle that's 150. The only difference is the angle that's 150 moved counterclockwise 150 degrees. The angle that's -210 moved clockwise 210 degrees. If you recognize every single one of these angles looks exactly the same. The only difference in their degree measure is how many times the terminal side swept through a rotation. When we talk about portions of degrees, we can work with degrees in decimals. However, we also work in minutes and seconds. So a minute, which we write as 1 minute, is 1/60th of 1 degree. A second, which is written as 1 second, is 1/60th of 1 minute, or it's 1/3600th of 1 degree. We'll do some examples now. The first asks us to name 2 angles coterminal with 70 degrees. That means we're looking for 2 angles that are going to look like a 70-degree angle, but that are going to rotate through either more than 360 degrees, or they're going to rotate negatively. So we'll do one in each direction. If I rotate through 360 degrees and 70 more, that will be coterminal with 70 degrees. And it's an angle of 430 degrees. We also could move backwards. We could start with our 70 degrees, and we could add a -1 times 360 to it. This gives us -290 degrees. You could certainly get adventurous, and you could multiply 3 times 360 plus 70, or 4 or 5 times 360 plus 70. That would also be coterminal. In the negative direction, you could multiply -3 times 360, or whatever value. Pay attention to the fact that we are always adding or subtracting multiples of 360 degrees. Here we're given a negative angle, and we're asked for 2 angles coterminal with it. So again, my initial thoughts are to add 360 degrees to this. So if I start with -225 plus 360, that gives us 135 degrees. I could add 2 times 360. I could subtract 360 degrees. I could subtract any multiple of 360. Every one of these will give me an angle coterminal with negative 225 degrees. The next section asks us to express an angle that is written in degrees and minutes as a decimal only. The first thing that we do is we separate the degrees. Now we know that 1 minute is a 60th of a degree, so we'll add 9/60 degrees to the 69 degrees that we have. This can be entered directly into the calculator, but if you do, make sure you put parentheses around your fraction. This gives us 69.15 degrees. Here, we're given an angle in decimals, and we need to convert this decimal to degrees, minutes, and seconds. Just like before, the first thing we do is we pull out our whole number. That's our degrees. So in this case, 53 are our degrees. Now we take the decimal and we convert that to the minutes and then the seconds. So to convert to minutes, you take what's after the decimal and you multiply it by 60. That gives you 43.26 minutes. So here we've got 53 degrees, 43.26 minutes. Now we don't leave minutes as a decimal. So we need to take the minutes, or this fraction of the minutes, the 26.26, we need to convert that to seconds. So we take 0.26, we multiply that by 60. And that's going to give us 16 seconds. So our final answer is that we have 53 degrees, 43 minutes, 16 seconds. From here, you should go to page 551 in your textbook and read the very top of the page regarding naming our angles. In the past, we've used letters like angle A, angle B. We'll continue to do that, but we will also use the Greek letter theta to name angles as well.